Look up at the night sky. Billions of stars, each one a colossal nuclear furnace, pouring unimaginable amounts of energy into the empty void. Our own sun, just one of these stars, outputs more energy in a single second than humanity has used in its entire history. Now, ask yourself a simple question. In a future where our civilization needs more and more power, why are we letting all of that energy go to waste? What if we could capture it all? What if we could build a cage around a star? In 1960, the physicist Nikolai Kardashev proposed a way to measure a civilization's technological advancement. It's called the Kardashev scale. A Type 1 civilization can harness all the energy of its home planet. A Type 3 can harness the energy of its entire galaxy. We are currently around a Type 0.7. We still have a long way to go. But it's the next step, Type 2, that sparks the imagination. A Type 2 civilization can harness the entire energy output of its home star. To do that, you would need to build one of the most ambitious engineering projects ever conceived, a megastructure so large it would literally encompass a star. This is the story of the Dyson Sphere. The concept was popularized by the physicist and mathematician Freeman Dyson in 1960. But let's clear up a common misconception. A Dyson sphere probably wouldn't be a solid, rigid shell. Building a single object that massive would be almost impossible, and its gravitational forces would be incredibly unstable. Instead, the more scientifically plausible idea is a Dyson Swarm. Imagine launching millions, perhaps billions, of self-replicating robotic construction drones. Their mission? To mine asteroids, comets, and even entire planets like Mercury for their raw materials. They would use these materials to build vast, independent solar collectors, each one a massive power station in its own right. These collectors would be placed in orbit around the sun, forming a dense, overlapping swarm of technology, capturing almost every single photon of light before it escapes into space. The energy collected would be beamed wirelessly to wherever it was needed. From the outside, our sun would slowly begin to dim in the visible spectrum, not because it was dying, but because it was being enclosed by a shell of human ambition. In its place would be a new kind of star in the sky, one that glows not with light, but brightly in the infrared spectrum, radiating the waste heat of a civilization that had mastered its star. So, what could we do with the power of an entire star? The answer is almost anything. We could power computations on a scale we can't even fathom, creating simulated universes. We could easily propel fleets of starships to other galaxies. We could power technologies that could manipulate space and time itself. The energy needs of every single human would be met 1 billion times over. It represents the ultimate energy security. Of course, the engineering challenges are monumental. The material science, the robotics, the sheer scale of the project is far beyond our current capabilities. But it's not impossible. It's an engineering problem, and humanity is very, very good at solving those. And this leads to a fascinating and slightly chilling question. If building a Dyson sphere is a logical step for any advanced civilization, where are they? Astronomers are actively searching for them. Using infrared telescopes, they scan the skies for stars that are unusually dim, but which glow brightly with waste heat. So far, we found a few strange candidates like Tabby's star, but none have been confirmed. Is the silence in the universe because no one has reached this stage? Or have they, and we just don't know how to see them yet? The Dyson Sphere is more than just a theoretical power station. It's a symbol of a civilization's ultimate potential, a testament to a species that looked at the awesome power of its star and didn't just admire it, but decided to harness it. It represents the moment we stop being planetary inhabitants and become true stellar engineers. What do you think humanity would do with that kind of power? Let us know in the comments below. And if you want to keep exploring the biggest ideas in science and future technology, make sure to subscribe to The Quantum Leap and ring that bell. Thank you for watching.